Okay, it is 3:30, which of course means it is time for After School STEM. So we've been doing these shows every day for the last, half a year at this point, 6 months, and I think we've missed one day on this. So for those of you who have been watching this whole time, welcome back. For those of you who are new, welcome for the first time. Hopefully you like what you see and keep coming back. For those of you who are watching on any given platform, just be aware we're streaming across a few of them. So if you're watching on Facebook, for example, I'd invite you to go follow our Twitch, twitch.tv/Headwater Science Center, or our YouTube. We stream live on all three of them. And so today what we're going to be doing is watching a video from YouTube that I found earlier today that I thought was kind of interesting, at least from the title sounded like it was kind of interesting. And I thought what we would do is take a little watch of that, and I'll kind of talk about my thoughts on some of the subject matter in that video as we go through it. It's a video from PBS Eons, which is a YouTube channel that I love and I've been watching for several years at this point. Plus it's PBS, so it's pretty reliable information if it's still up to date, which with this particular subject, information is kind of always changing with it. So it'll be interesting to see what's different in this video versus like when I was in college learning about this stuff versus maybe what's true now, because this video is actually a couple of years old. So I think with no further ado, we'll hop right into this. Swap my overlay, get my video started here.
And I belong to the only group of hominins on the planet Earth today. We are the lone twig left on our branch of the family tree. But we weren't always
And so this video is called When We Met Other Human Species.
Alone. 100,000 years ago, Eurasia was home to other hominin species, some of which we know our ancestors met and spent some quality time with. Some of them we've known about for a while, like the Neanderthals, whose fossils we've been digging up since the 1800s. But some of them are more recent additions to the family tree, like the Denisovans, who we may, on this channel, have called Denisovans, but we have been informed that it's Denisovans. The Denisovans.
And so going back to what he just mentioned about Neanderthals, where they've been getting dug up since the 1800s, there's some fun history with that, where like early on in the sort of the paleoanthropology world, one of the big motivating factors for people kind of going out and trying to dig stuff up was all these countries that were trying to like kind of prove that they were like the origin point of humans. It's like as evolution is starting to like gain some mainstream acceptance, all of a sudden you have all these countries saying, oh well, if humans derived from like a single location, if that location is within our country, that means we are the most closely related to the original humans, which means we're the best. And that was like a pretty pervasive thought process for a lot of, like I said, early anthropology works. And so the Neanderthals represent one of these fossil groups that was found kind of as a product of that. And they're named after the Neander Valley, which is in Germany. And so, like I said, early on in the paleoanthropology as a field, the Neanderthals were something that the Germans in particular were trying to push really, really hard as a direct human ancestor, and in particular a very early direct human ancestor. Because remember, this is all also stuff that's happening way before we have things like carbon dating that we can use to actually accurately age things. And so it's basically just like, the Germans have the Neanderthals and the French have Cro-Magnon, and they're just arguing about like, hey, who's older? It's definitely ours. No, it's definitely ours, without a whole lot of anything to base it on. And obviously the further down the road, it's now largely considered that Neanderthals are not modern humans at all. They're not even the same species.
Denisovans were discovered almost by accident in 2008, and we know them only from a few fossil bones and from the DNA of their living descendants. That surprising discovery has opened our eyes to the fact that our ancestors met and even mated with other hominins.
And so these Denisovans that he's mentioning are something that was like just getting kind of discovered and was like just on the cusp of like having stuff being published about it, kind of like when I was in college in like the early 2010s. Like I because I was in classes that were specifically about this, I was aware of them, but like the big publications for them hadn't come out yet. So I honestly don't know a whole lot about them other than that they're from like Russia someplace. So maybe there'll be a little bit more in this.
Anthropologists are following the genetic traces of these ancient interbreeding events, traces that many of us carry with us today. Thanks to this research, we're starting to better understand how and even where modern humans paired up with other hominins, giving us a more complete picture of the history of our species. And we're starting to tackle some really exciting questions, like what's our inheritance from that time when we met up with other human species, and why are we the only ones left today? As we get closer to answering those questions, we're starting to see that maybe part of our success as a species has to do with those other hominins that we encountered in our travels around the planet. Neanderthals lived.
And so the other thing, obviously, that's coming up here as he's mentioning potential interbreeding is a thing that I bring up in seemingly a lot of my talks is what's a species? They're talking about Neanderthals and humans as if they are completely different species, but also implying that they are able to successfully interbreed with one another and have viable offspring, which goes against the species definition that you generally learn in school. And as I said, maybe they'll go into that a little bit more here. But interesting that we're a minute and a half into this video and, species concept stuff is already coming up again.
Throughout Europe and from southwestern to Central Asia. We found their fossils from Portugal and the UK in the west, all the way to the Altai mountains of Siberia in the east, and down to Israel in the south. The oldest Neanderthal-like fossils come from a site in northern Spain called Cima de los Huesos, literally the pit of the bones, dated to about 450,000 years ago, while the most recent come from a handful of sites across Western Europe that date to around 40,000 years ago. Anatomically, the Neanderthals were very much like us, with few differences. They were relatively short and stocky with robust limbs and big brains. They had heavy brow ridges, large noses, and brain cases with more of an oval shape than the round ones of Homo sapiens.
Yeah, so Neanderthals actually had, on average, a bigger, heavier brain than anatomically modern humans did, than Homo sapiens did. Which is kind of an interesting thing because, generally when you think Neanderthal, the stereotype is that they're, dumb cavemen, but it's a bigger brains than we have.
And we know that they weren't just dumb cavemen. They controlled fire, made stone tools and spears, made jewelry from eagle talons, and cared for injured members of their groups. And our ancestors clearly recognized them as being like us, enough so that we interbred with them. We know this because researchers have sequenced the Neanderthal nuclear genome, originally in 2010 from bone fragments found in a cave in Croatia. And by comparing that genome to those of modern humans from many different populations, we can find out how much Neanderthal DNA some of us still carry. Although original estimates were around 4%, more recent studies have suggested that living people of European and East Asian descent have between 1 to 2% Neanderthal DNA in their genes. Meanwhile, people native to sub-Saharan Africa don't have any Neanderthal DNA, indicating that their ancestors never encountered Neanderthals. As we find more fossils to sample, we can tell that these interbreeding encounters happened more than once, and our genomes can even shed some light on when they happened. For example, genetic material extracted from the left femur of a modern human male who lived in Siberia around 45,000 years ago has been found to contain Neanderthal DNA. And researchers were able to measure how long the Neanderthal segments of his genome were compared to the same segments in living people. It turned out his Neanderthal sections were longer than modern humans, suggesting that he wasn't that many generations removed from his Neanderthal ancestor. In fact, the researchers were able to estimate that this Siberian man was the product of an interbreeding event between Neanderthals and Homo sapiens that occurred 50,000 to 60,000 years ago, just 10,000 years before he was born, give or take a few thousand years. And this was likely when modern humans migrating out of Africa encountered Neanderthals in the Middle East. Likewise,
and so the assumption he's making here, the idea that he's running with, is the Neanderthals and the Homo sapiens being I said very distinct separate populations to begin with, because it talks about how Homo sapiens are leaving Africa and then encountering Neanderthals after they leave. But one of the interesting things that he, so far at least, has not mentioned is like, well, how'd the Neanderthals get there? Like, what was the initial population group that left? Because if there's not Neanderthals in, you know, that whole path up from, you know, Eastern Africa, where the anatomically modern humans are generally considered to have begun, all the way up into Europe, that means that some other precursor to Neanderthals must have existed before then. And that is generally true. It's depending on who you ask, it's called Homo antecestor or Homo heidelbergensis, you'll see it. But what's interesting with that is, again, now we're introducing like multiple different species into the mix here, where now, rather than just dealing like, oh, there's a Homo sapiens versus Homo neanderthalis dichotomy here, all of a sudden now you're moving into like, okay, at what, if Homo sapiens can interbreed with Homo neanderthalis, but Homo neanderthalis aren't even the ones that left from Europe, does that mean that Homo sapiens and Homo heidelbergensis are the same? And generally speaking, Homo heidelbergensis isn't even generally considered to be the one that left. It's again, depending on who you asked, either Homo erectus or Homo ergaster. And now all of a sudden you're back a few million years on this, where are you drawing a line on what's a species and where? Because theoretically, a Homo neanderthalis, in whenever the encounter point was for Homo neanderthalis and Homo sapiens, is less genetically similar to a Homo sapiens than the Homo erectus that originally left Africa is, because it's been an isolated population for longer by that point. So if you're considering Homo sapiens and Homo neanderthalis to be the same species based on their ability to interbreed, then you pretty much are buckling yourself into saying everything all the way back to Homo erectus is the same species, which I said generally we don't do, but it's this kind of an interesting thing, like I said, within this sector, where we love to sort things into these small groups, and we love to try and come up with definitions for these small groups, but they're always changing, and it's just kind of an open secret within particularly all this like paleoanthropology, paleobiology stuff, that like there's just not a good definition for any of this. Like, we're just making it up, kinda.
40,000-year-old jawbone was found in...
Like I said, he just doesn't address it at all. He just like talks about it as though it's like a given that we just like understand what it is. But the reality is, once you get past surface level on this, nobody does.
Romania in 2002, which provided some of the earliest evidence of modern humans in Europe, and it was found to have some anatomical similarities to Neanderthals. When its genome was sequenced over a decade later, that human was found to have had a Neanderthal ancestor only some 4 to 6 generations back. Between 6 and 9% of its genome was Neanderthal. So using fossils like these, researchers have been able to determine that Homo sapiens bred with Neanderthals several times in different places. But how did all of this interbreeding change us? Well, sometimes not very much. The genome from that Romanian jawbone suggested that population didn't contribute much to the DNA of living modern humans. But sometimes these encounters had a big impact. For example, 2 genes that play important roles in our immune response system seem to have passed from Neanderthals to people of Eurasian descent. One of these genes, known as STAT2, is part of our immune system's signaling response when we get a viral infection. And we know that the Eurasian version of STAT2 comes from Neanderthals because it isn't found in sub-Saharan Africans. Plus, molecular clock studies have found that the Neanderthal version of this gene appeared in the Eurasian genome long after the evolutionary split between Homo sapiens and Neanderthals, so it must have come from interbreeding. Meanwhile, members of many East Asian populations have been found to carry a gene known as HYAL2, which is involved in skin cell repair after skin has been exposed to the sun's UVB rays. In other words, a sunburn. And this gene also seems to have come from the Neanderthals, likely a helpful adaptation for modern humans spreading across Asia. These genes are both examples of a phenomenon known as adaptive introgression, where genetic material from one species moves into the gene pool of another species and then is selected for so it sticks around. But these genetic contributions can also have a downside. Introgressed genes that were once beneficial can become less so over time as the environment in which natural selection is taking place changes. For example, there's a gene that's involved in the rapid coagulation of blood, which used to be really beneficial before medical care was available. But also that gene increases the risk of blood clots, and this gene too seems to have come from interbreeding with Neanderthals. But importantly, Neanderthals are not the only hominins that we got to know so intimately. In 2010, paleogeneticists announced a shocking discovery. A site known as Denisova Cave in southern Siberia had yielded ancient mitochondrial DNA from a previously unknown hominin. Earlier work there had turned up evidence of modern humans and Neanderthals, so the researchers were expecting that the DNA they extracted from a pinky bone found there would also be Neanderthal. But it was not. Almost a decade later, we have 7 fossil bones with this unique genetic signature. There's the tip of a pinky, there's 3 molars, a sliver of long bone, and a piece of skull cap, all from Denisova Cave, all dated to between about 52,000 to 195,000 years ago. And there's also a single partial jawbone from the Tibetan Plateau, dated to at least 160,000 years ago. This new group of hominins has yet to be given a scientific name because it lacks a type specimen, a fossil that's complete enough for future finds to be compared to. So
Type specimens are a really good concept to talk about too, where again it ties back to kind of species-y type of stuff, but basically you find a fossil and it's generally going to be one of the earliest, one of the first fossils of a given species, whatever a species is, and basically you're looking for a fossil that is in good enough condition that now becomes the fossil against which all other future remains are compared to. So it ends up being a very interesting thing with like you're determining based on morphology, which saying things look alike and calling them the same species based on how much they look alike has its ups and downs. But also you're, taking a single specimen, saying that it is representative of an entire species because you're comparing against that single specimen. And so differences within a species can certainly end up, on occasion, probably result in individuals that they themselves would have recognized each other as being of the same species, ending up getting separated into 2 separate species because of, things like size, for example. We think about like the boas that we have on the exhibit floor here, where we have a female boa that is 3 times the girth of our male boa. Probably not 3 times the girth, 3 times the weight of our male boa. And it's entirely possible that if you, were to go 200,000 years in the future and someone found the remains of those 2 snakes, they would say, okay, these are similar but of very different sizes, so we're going to call these 2 separate species, even though obviously they recognize each other as being of the same species. So working with old stuff is hard, man. Like, working with stuff that you can't observe live in person is so tricky, because like you can think of any sort of context, any sort of presumption that you're going to make about anything, and then come up with some weird niche situation where it doesn't make sense, and all of a sudden your whole model falls apart. And that's like the biggest struggle with doing anything with paleontology or paleobiology.
For now, they are informally known as Denisovans, and they are essentially a ghost lineage within our own ancestry, a branch of the hominin family tree that lacks a fossil record. Now, it could be that there are other Denisovan fossils in collections around the world that just haven't been identified, but because there's no type specimen and most fossils don't have DNA that can be extracted, we just don't know for sure. But we have sequenced enough of the Denisovan genome to be able to tell some of their story. For instance, their mitochondrial DNA, which is passed down from mothers to their offspring, suggests that the last common ancestor that we shared with the Denisovans lived about 1 million years ago. But the nuclear DNA of Denisovans, which accounts for most of their genome, is actually more similar to ours. So this might be a sign that Denisovans also interbred with some other hominins within our lineage, like Homo erectus. Today, we find small amounts of Denisovan DNA in populations in East and South Asia, and up to 6% Denisovan DNA in some populations of Melanesians in the Southwest Pacific. And the variations we see between the DNA and modern people and the ancient genomes we have from Denisovan fossils suggests that there were interbreeding events with at least 3 different groups of Denisovans, so it didn't happen just once or in just one place. And some of these genetic contributions are really important. Take the gene known as EPAS1, found in many people native to the Tibetan Plateau. This gene is associated with differences in hemoglobin concentrations, and at high altitudes, more hemoglobin means more efficient oxygen transport. This gene seems to have been introduced by the Denisovans and was strongly selected for because of the advantages it offered to modern humans living at high elevations. So we know that many of the hominins that we used to live and hang around with were really well suited to a lot of environments. So why aren't there populations of these other hominins walking around today? Well, anthropologists have been thinking about that for a long time, especially when it comes to the Neanderthals. The longest standing explanations for their disappearance have been that climate change, competition from modern humans, or some combination of the two caused their downfall. And there's evidence that there were cycles of intense cold and dryness in Europe between 44,000 and 40,000 years ago, which might have caused Neanderthal populations to decline, leaving them vulnerable to extinction. Other researchers have modeled the distribution of Neanderthals and their habitats and suggest that those habitats were becoming more fragmented by changes in climate. As for the impact of modern humans, we know that we met Neanderthals, but there's no evidence of violence or direct competition between the two groups. So some researchers have suggested that it was just the continued migration of modern humans from Africa into Eurasia that pushed Neanderthals into extinction, and that we weren't better adapted than they were, we were just more numerous. Other researchers think it might have been that we had better clothing and technology, and that social factors like long-distance trade may have given us an advantage. Or maybe the Neanderthals were just on their way out anyway. The genetic information we have suggests that their populations were smaller than those of modern humans, and that inbreeding might have occurred more often, resulting in decreased genetic diversity. This generally makes populations less adaptable to changing environmental pressures. As for the Denisovans, well, we only just realized that they existed at all, but it's possible that some of the same factors that brought about the end of the Neanderthals affected them as well. And as a result, we are the only species of hominins left. But it's kind of remarkable to me how close we were to that not being the case. But this doesn't necessarily mean that Homo sapiens was somehow more fit for survival from the start, because we really weren't. The fact is, our species became better adapted to local conditions precisely because we interbred with other hominins that had evolved to fit those environments. The other species, like the Neanderthals and the Denisovans, contributed to our survival in these new landscapes. They helped us tolerate new conditions like high elevations and intense sunlight. They helped our bodies become better at signaling when we were sick, and they helped our blood clot faster when we were injured. The genetic legacy they left us is part of the secret of our success. And in a sense, those hominins didn't completely disappear, because parts of them live on today in us. They live on in our own genes, reminding us of a time when we weren't alone.
Yeah, and again,
Thanks to this month's Eon
weird to be like, oh yeah, they're extinct, but also genetically we have a bunch of their DNA in us, so they're not extinct. We're just a hybrid species. Is what. But anyway, I said, saw the title of that video and thought it sounded interesting, and it was interesting. And again, gave me a chance to talk about one of my favorite subjects, which is how species definition stuff is super weird and super fun. And, you know, it's a really interesting subject to think about because, you know, we like to define things in a way that don't have exceptions to rules, but we haven't quite found a species definition that accomplishes that for us. And maybe we will someday, but hasn't happened yet. But I think we'll wrap it up here. Thank you all for watching. Again, we do these shows every day at 3:30. So what's tomorrow? Saturday? I don't know what's going to be happening Saturday. Oh, it's a snake feeding day tomorrow, actually. So snake feeding will be tomorrow. I know we had some technical issues with that last time, but hopefully we've got those sorted out now. So Ridley, one of our new staff, is going to be doing the snake feeding. If you want to come and visit us in person, we are open right now at the Headwaters Science Center. So we are open Friday, Saturday, and Monday from 9:30 to 5. And we are open Sunday from 1 to 5, so you can come and visit us in person anytime then. We are also been accepting group visits, so if you represent a group that wants to come in and do a visit, we are taking those on Tuesday, Wednesdays, and Thursdays. So the days that we're not open to the general public, we are taking group visits right now. And, you know, if you're interested, call now, because those days have actually been booking up very quickly. There's not a whole lot of days left in when it comes to May and even June. But thank you to Beltrami Electric Co-op. They've been underwriting us or these 3:30 shows specifically for a couple weeks now. So big shout outs to them. Thank you for that. We are nominated currently for the Best Museum in Minnesota by the Star Tribune, Minneapolis Star Tribune. So you can go to our website or you can go to their website and give us a vote there. We'd much appreciate it. Be some good free advertising for us. We are in the Minnesota Fun section under museum. So go to vote, go to Minnesota Fun, go to museums, and we're under there. So we appreciate your vote. What else we got? That pretty much covers it. Again, thank you all for watching. Keep tuning in. We're going to keep doing these for the foreseeable future. And we